Now I'm going to show an example of Taylor series for the equation f of x equals to ln x. So this is how the question will be. So what is the Taylor series for the function f of x equals to ln x centered at a equals to 1? First, let us write the formula for the Taylor series. So we can write f of x equals to f of a, that is, in our case it is 1, plus f prime a x minus a to the power 1, there is a multiplication here, plus f double prime a x minus a square divided by 2 factorial, plus f triple prime a x minus a whole cube divided by 3 factorial, plus fourth derivative of f of a times x minus a whole to the power 4 divided by 4 factorial, and so on. If we look closely, we can see a pattern here, that is 2 factorial, 3 factorial, 4 factorial, and so on. So the factorial is increasing by 1, and also for the sake of understanding, we also can write here 0 factorial divided by 1 factorial. So this is divided by 0 factorial divided by 1 factorial, because 0 factorial we know is always equal to 1 and 1 factorial is always equal to 1 too. So whenever we are dividing with 1, the value stays the same. So the pattern we can see is that 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, and the next one will be 5 factorial, and so on. So all the denominators are factorials of 1, 0, 1, 2, 3, 4, 5. So here we can see a pattern. So it is very important to understand the pattern here. So here we can see in the first term, x is not differentiated at all. So f of x is not differentiated at all with respect to x, which means we have 0 differentiation here. And there is no x minus a, that means the power of x minus a equals to 0. Even if we calculate that there is an x minus a, we can say that the power of x minus a equals to 0. And it is being divided by 0 factorials. So in the first term we can say here is no differentiation, the power of x minus a equals to 0, and it is being divided by 0 factorial. And in the second term we can say f of x is differentiated once, power of x minus a is 1, and it is being divided by 1 factorial. Here the third term we can see that f double prime of a, so it is the second order differentiation of f of x. So here we can see that f of x is differentiated twice, and the x minus a has the power 2, and it is being divided by 2 factorial. Here f of x is differentiated thrice, x minus a has the power 3, and it is being divided by 3 factorial. So we can clearly see the pattern here. Here it is 1 1 divided by 1, 2 2 divided by 2 factorial, 3 3 divided by 3 factorial, 4 4 divided by 4 factorial, and so on. So this is an easy way to memorize the formula for the Taylor series. So now let's try to solve the math. So the first thing we have to do is find the derivative of f of x with respect to x. In this case, where x equals to a equals to 1, and we're going to find eventually the first derivative, the second derivative, the third derivative, the fourth derivative, and so on, as many as we need in this math. So we know f of a equals to ln a here. So So here we know f prime x is going to be 1 by x, that is equals to x to the power minus 1. If double prime x is going to be minus 1 comes to the front, x minus 1 minus 1, that's going to be minus 2. If triple prime is going to be, we're going to take this minus 1 and we're going to have minus 2 x to the power minus 2 minus 1, that is minus 3. That will be equal to 2 x to the power minus 3. And if 4x is going to be minus 3 times 2, that is minus 3 to the 6 x to the power minus 4. So basically we need all these derivatives at x equals to a, in this case which is 1. So now we can write f of 1 equals to 0, that is ln 1 equals to 0. If prime 1 equals to 1, if double prime 1 equals to minus 1, if triple prime 1 equals to 2, if 4 1 equals to minus 6. So what we're doing is basically we're putting 1 in here and just finding out the value. So now that we have find out the derivatives of all these numbers or all these equations, we just have to now plug these values in here and find the solution and find the appropriate series. Now by plugging the value in this formula, we get ln x equals to f of 1, that is f of 1 is 0, plus f prime 1, that is 1, times x minus a, that is 1 to the power 1. So then plus minus 1 f double prime 1 equals to minus 1, x minus a whole square, that is x minus 1 whole square, divided by 2 factorial. So this one is done. So since it is minus and this is plus, we can just change this plus to minus and delete this minus from here. Plus triple derivative of x, f of x is 2, then x minus 1 whole cube divided by 3 factorial minus 6 x minus 1 to the power 4 divided by 4 factorial, and so on. Now we can simplify it as ln x equals to x minus 1. We can write a 1 factorial here, that's the same thing, minus x minus 1 square divided by 2 factorial plus x minus 1 whole cube divided by 3 factorial, and here is a 2. So here we can write the 3 factorial as 3 times 2 times 1. So the 2 and 2 get cancelled away, so the denominator will be 3. So we can just write 3 here instead of the 3 factorial and delete the factorial. And also we know here 2 factorial is 2 times 1, that is 2. So we can also write here 2, and 1 factorial is also 1. So we can, instead of 1 factorial and 2 factorial, we can write here 1 and 2. And then we have minus 6 times x minus 1 to the power 4 divided by 4 factorial, and this 4 factorial we can write as 4 times 3 times 2 times 1, and 3 to the 6. This 3 and 2 can be cancelled with 6, so here is we are left with 4 only, so the denominator will be only 4, and so on. So here we can see a pattern developing. So the denominators are incrementing by 1, so 1 2 3 4, and the power of corresponding numerators are also 1 2 3 4. So this pattern keeps on repeating and going on. Not repeating actually, that's gonna be 5 6 7 8 and so on. So this is a Taylor series. As we know that a series is always represented as sum, so we have to find a way how we can denote this, or how we can represent this series in the summation formation. So let's write it in summation notation. Ln x equals to summation n equals to 0 to infinity. So if we consider this as n equals to 0, we can see there is 1. When if we consider n equals to 2, or sorry, n equals to 1, the power is 2. N equals to 2, the power is 3, and n equals to 3, the power and the denominator is 4. So it's gonna be n equals to 1, and this is n equals to 0. So here we can see the power is 1, so 0 plus 1, here it is 2, that is 1 plus 1, here it is 3, that is 2 plus 1, but n equals to 2 here. So we are just gonna write here plus x minus 1, and in the place of power we are gonna write n plus 1, because the power is always 1 more than n. And it is the same for the denominator, it is also n plus 1. Since here we can see n equals to 0, and it is 0 plus 1, n equals to 1, it is 1 plus 1, n equals to 2, it is 2 plus 1. And the last thing we can see here, that this series is basically an alternating. Here it is positive, negative, positive, negative, positive. So we already know that when we have a positive power on a negative number, the number becomes positive. It is so I meant to say the even power. When the power is not positive, when the power is even, the number becomes positive. So 4 is a even number, so it's gonna be a to the power 4 minus a 6 a to the power 6. But when the power is odd, the sign doesn't change, so it's gonna be a minus a cube is also minus a cube, minus a to the power 5 is gonna be minus a to the power 5, and so on. So since here the signs are alternating, that is positive, negative, we have to multiply it with plus 1, minus 1, plus 1, minus 1, plus 1, and so on. So how are you going to do it? First we're going to multiply it and put a minus 1 here. We're going to take a look at the first term, that is positive. So we can either use here minus 1 to the power n, or minus 1 to the power n plus 1. So which one are we going to use? So since the first term is n equals to 0 here, if we put the value n equals to 0, this is coming out to be positive 1. And also we see that the first term is positive, so we are going to use the minus 1 to the power n here, because if we use n plus 1, the first term is going to be negative, that we don't want, because the first term is positive, as we can see. So we can simply write it as ln x equals to summation n equals to 0 to infinity minus 1 to the power n x minus 1 to the power n plus 1 divided by n plus 1. So this is the Taylor series for f of x equals to ln x centered at a equals to 1.